I think the one we can probably spend the most time on is 7.
Right, yeah. I think that's the one that gave me the most trouble.
Yeah. And it's probably the most difficult. And the reason, I guess, too, is because it's, you know, you're refactoring, you're refactoring, and it's kind of, you're like, when is it ever going to end? And you work out this problem, and it takes a whole page, and you get down to the bottom and find out there's not an answer.
Yeah.
Yeah. All right, so let's turn to page 630, your Chapter 8 test. And one thing I have to caution you on the Chapter 8 part is making sure, is it a square or is it a cube? Always making sure what it is. So like the cube root of 27 would be 3, right. And if we had, let's see, looking at, say, the square root of 32. Because as you went through this chapter, you noticed that they used a lot of the same numbers a lot.
Mm-hmm.
So 32, probably the first thing, what's the first thing that came to
16.
Right, very good. So that would be 4 square root of 2. So you see you're going to be fine. The other thing was if we can't have a radical in the denominator. So if we had something like the square root of, this is number 9, 2/3. How would I get that square root out of the denominator?
You got to times it by the radical of 3.
Right. But then I would just have the square root of 6 over 3. All right. So you know all your rules, and that's the main part. How about number 12?
You have to separate the top. Well, first you have to. I don't remember which way I started. Because you do it 2 different ways.
You can. I kind of like to go ahead and do this and get it smaller because to me working with big numbers, so I'd probably go ahead and take the square root of this.
It'd be 4x squared, y squared.
So we'd bring out a 2
X,
y, and underneath we'd be left with a 3
y.
Now you know, this might be something you probably already know, but if it's a square, you can use this 2 to kind of go in here. 2 will go into x squared, 2 will go into 2 one time, so I can bring 1 out. And so 2 will go into 3 one time, I can bring 1 out, and I'm left with 1. So if this was, say, a 7, I could have said, well, 2 goes into 7 3 times, so that meant I can bring out 3 y's. So that's good. Okay. All right, so now we're down to this.
And then multiply by the radical of 5.
Right. Very good. So we have 2xy square root of 15y over 5.
You don't multiply the 5 to the 2?
No, only under radicals.
Okay.
Good question. Only under the radicals. All right. And you could do one like number 14. When you have something out in front, you just bring it out and multiply it, right? So Dama, where do you live? I can't remember. Do you live around?
I used to live right in front of Western High School, and now I live in Broadway.
Okay. Okay. So you're close.
Yes, ma'am.
And did you take this distance because you couldn't come seated, or?
Well, I took, like I said, most of my classes were in Lillington, and they canceled that class because there was only 3 students. So, and they didn't have a number to get up with me because my parents had a big fallout. So I moved, and that's what happened. In the 2x squared, can you pull out the x and leave the 2 under?
Yes. Okay. So here we would have, I kind of just do them up top. So I'd have 9 times 2 would be my 18, so I have 2x. I can bring out a 3, and I'm left with 2. And over here we would bring out an x, and we're left with a 2, right?
Yes, ma'am.
So then we have 6x square root of 2 plus 5x square root of 2. And can I do anything else with that?
Add the 5 and the 6 together.
Right, so we got 11x square root of 2. And we can add those together because the square roots are the same.
Yes, ma'am.
So I kind of think of x, if you can add x's and x's, you can add square roots and square roots that are the same, and you can add i's and i's that are the same, so they're, if you can kind of keep that same thing going, you can always add them if they're the same. Okay? Alright. And as we talked about in chapter 9 with rationalizing the denominator, how about number 19? We may be done before. Since you're so knowledgeable there, we can do what we need to do and answer your questions and be done.
Do you multiply by radical 7 plus radical 3?
Yes.
Do we do the opposite?
So we do the opposite. Minus the square root of 3. And the square root of 7 minus the square root of 3.
Stop you looking there.
So we would end up with what? 7 minus the square root of 21. I'm taking this and multiplying it times everything.
Okay.
And then minus the square root of 21. And we'd have a positive 3.
Yes, ma'am.
Okay? And then on our denominator, we'd have 7 minus 3. So I would have 7. Well, I'll put my 7 and 3 together, so I'd have 10. Minus 2 the square root of 21. So we can add those together over 4.
Yeah.
And we have something in common.
Divide by 2.
2. So we have 5 minus the square root of 21 over 4. And we can cancel. And my final answer would be 5 minus the square root of 21 over 2. Okay. Okay. And then, how about one like 21? If we have that radical, we have that number there, before we can actually square that side, we need to do what?
Subtract that 2.
Right, very good. Okay. Square root of 2x minus 1 plus 2 equals 7, so we subtract our 2. We have the 2x minus 1 equals 5.
Plus 1. It's plus.
Was it a plus?
Yes, ma'am.
Okay, thanks. Okay. So then we square that side and square this side. And we have 2x plus 1 equals 25. Subtract our 1. And we have 2x equals 24. And divide by 2 and divide by 2 and x equals 12. And one thing with these, it probably says in your directions, be sure to check all solutions in the original equation.
Mm-hmm.
So always read the directions above the line.
Because 12 could go into it and not fit and
Right.
work.
So if you read the directions and it says check, make sure you check it. Because that's kind of like a hint, you know.
Why does that work out like that? Why do you get a number, but then when you plug it back in, it's no solution?
Because we are subtracting that 2 from both sides, and if we take that 12 and put it in here, let's just see what happens. So that would be 24 plus 1, which is 25, right? Which would be the square root of 25, which would be 5. And 5 plus 2 makes 7.
Okay, so that one
So
doesn't work.
that one does work. Because sometimes it could end up being a negative 7, because when you square a negative 7, it makes it a 49.
Okay.
So that could be a possibility there. Okay. It is kind of frustrating to do all that work on now that it's written on an answer. You're like, well, why do they make problems that don't have answers, right?
Yes, ma'am.